Welcome back YouTube, and I have an idea. This is a 240 volt light bulb bayonet cap, and I want to use this in a new location, but it's only got DC power, so I want to make this a 12 volt DC powered light, not a 240 volt AC powered light. So can I do it? So this is also a PIR light with a sensor on it to turn it on and off. I don't care much for the PIR, I just want it as a normal bulb. So first thing I've got to do is crack into this, and this is done by, can I do it one hand? No. Yes I can. Come on, be a man. Pop! See, just like that. No editing required. And inside we have the wire that goes to the PIR sensor that's in there. Again, don't really care about that. And the board of LEDs. And if we look in here, we should see. What can you see? It's because it's all white, screeny stuff. You can have them with the light. They're all wired in series. So the power comes in here. It goes up to that one, then through to that one, then through to that one, then through to that one, all the way around, back again. So I reckon this will be a couple of 100 volts across here, because these are going to be multi-chip LEDs, so they'll be like 9 volt something per LED. But the first thing we've got to do is measure what voltage these LEDs are at. And two ways we could do this. We could power this up and put a meter across it, or we could just put some flying leads across and power up each LED individually. I might see if I can pull this PCB out of here. Let's see if it's glued in. Get a screwdriver and then try and pull it out. I'll do that now. LED board has been removed. It did require a fair bit of prizing. It's quite well glued in there, but a screwdriver down the edge. Pulled it up, and inside is this little circuit board, which also is quite glued in. So I don't want to break the connector at the end because I need that connector. So I wonder if I can pull it up or if I need to do anything else to get in there. Can we see what's in? Look at that. Can I see what's down in there? Looks like there's some wires down the bottom there. So hopefully, normally what you can do is prise out these little pips. So I prise out them little pips, and hopefully they're just the wires that hold that board in. Let's give that a go now. So I've just managed to get a knife inside the pip and prise it up. You see it's got little barbs on it. That should pull up all the way, and whatever's trapping in there should be a little wire that's pushed over. And we should be able to get to the bottom of that. So I wonder if I can just pull it out. No, we need to get something underneath it. Small pair of cutters, pull that out, and we'll see what's in there. And there you go, the pip's out, and as expected, a wire. So I'll do the same for the other side. And then a bit of persuasion using some pliers. And whatever glue this is should hopefully give, and the board should come out. Hopefully. I now have an empty bulb case with all the required bits to make a bulb, which is what I want. This is the circuit board that was inside it, and pretty standard. These are the two wires that went on them pips, and it just looks like a simple converter. So you've got rectified voltage up to 400 volts, and switch my power supply down to 90 odd volts. It looks like there's a 5 volt line here because we've got this, what's it called? PIR sensor switch. And that probably goes into there. Transistor. Yeah, it says nothing exciting on there, it's just standard. I managed to do that whilst removing it. But yeah, so we'll just cut this board off here and we'll power up, solder some wires on, see if we can power up one of these LEDs. So at 5.2 volts and 7 milliamps, we have a light. So that is indeed working, and 5 volts is not that much to light these LEDs up, so that's promising. How much current do we want to pull out of it? So what we need to do is look at this. This is originally a 12 watt light. So how many chips we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 watt each, 5 maths. Using some maths, if we have a 5.2 volt drop across the LED, gives us 1 watt power. That's 190 milliamps. We don't want to drive it anywhere near that high, so we'll do, you can say 50. Oh, 50 milliamps. That should be plenty bright enough. That'd be 260 milliwatts, so a quarter of the rated power. So we set our power supply to 50. That'd be absolutely fine. Let's see what that looks like. There's 50 milliamps, and yeah, that is definitely bright enough. It's not getting particularly hot, but it's a good spread of light. And this is only from one LED. Imagine what all 12 will be like lit up. So that's pretty good. And the voltage that is running at 50 millivolts is 5.7. So there we go. So we can work out what our voltage drop would be. So if we did it across a let's go back to resistor calculator. You want to do a 5.2 volt drop. You want to have a supply of 12 volts, a current of 50 milliamps. It's a 206 ohm resistor. That works. Another thing we're going to have to do as well, because these are all soldered in series, we're going to have to cut the tracks. So if you can see the copper there between the two resistors, I'm going to get a Dremel and just cut down there and isolate each individual LED. So I shall do that now, and this may take some time. And fun with a Dremel later, I believe all the tracks are cut and isolated. So I need to give this board a bit of a clean and a check with a meter just to make sure it is isolated. But that's fairly well done. There's some cuts around it to cut the tracks. Well, it's lit and that's quite bright. And that's 2 LEDs running in on 12 volts. And I'll show you what I've done. So I've added 220 ohm resistors to each LED, one on the plus, one on the negative. And then that all goes down to 2 channels. So I have to do that for all the LEDs. So there's going to be quite a lot of resistors in here. They're 1/4 watt resistors, so it should all run nice and cool because they're only dissipating, I think it's a 1/4 watt per 2, so it's half of that. So they're half underrated, if you see what I'm saying. So I shall populate all of this and then stick it in the bulb. But that's the general idea. I might have to do this another day. It's getting a bit late now, but I'll carry on the video later. So this is a new day, and I've been soldering for a few minutes. I'll say hours, but it has been hours. And I've got this really bright. Oh, the camera does that quite well. Oh no, there's 2 that aren't lit. I'll have to check my soldering. But anyway, it's bright enough. Look at that. Ooh. So yeah, so that's running off 12 volts, and this is the power it's using. 12 volts. Can you see that? 85 watts. Can't bend my hand that way. So you can do the maths and work out how much wattage that is, but it's not very much. And I realised I'd been a bit thick. And I was a bit thick because my original intention was to have 2 resistors per LED. And because these are 5 volt LEDs, and I suddenly thought this is a 12 volt supply, I could just put 2 LEDs in series. So even though I cut these, I've had to relink them together. So that's what these little links are. So I've got 1 resistor across 2 LEDs. So each group of LEDs got a resistor. There's less voltage to drop across the resistor, less power loss, just better. So then go through there. So what I've got to do is wire that to that. So here's the bulb, and there's the wiring. Goes into there. Just put these little lugs back in, and I've marked it red for positive, black for negative, because of course it's now DC and it's polarity sensitive. I was thinking about putting a bridge rectifier in here originally, but then I thought, well, if it's LED and that soldering is absolutely superb and will never fail, there's no point ever taking it out. So what's the point of? I mean, it's only ever going to go in one socket, so why bother? And it's, you know, another loss. So yeah, we'll stick it back together again, get a holder, plug it in, and see what it looks like lit up, all complete. And this is what it looks like in a lighting fixture, a normal light bulb. I mean, you'd be hard to press to tell that's any different to any other light bulb. But it is now 12 volts instead of 240 volts, DC instead of AC. And it works! So there you go. There is a light that runs, and I should leave it running for a few hours just to make sure it actually doesn't get really hot or melt or explode or anything silly like that, but I'm sure it won't because it's only using a small amount of power. And there we go. One converted light bulb. Cross all that off because it doesn't mean anything anymore. And for now, I shall see you later. Goodbye.